Hello, algebra students. I got to tell you, it was a joy to see your faces on Thursday as many of you realized the Pythagorean theorem without being told it. It was awesome. Great job. Now you got to take that great feeling you had and remember what produced it. Not me telling you how to do something, but you figuring it out. And believe that you can, because there are more of those great feelings coming. Sometimes there'll be some frustrating feelings because you might not be so sure how to do it, but that's okay. That's the struggle produces the learning. So, at least that's been my experience. All right, so we learned the Pythagorean theorem, and we learned that, if we have a right triangle, then the square of the sides, the sum of the square of the sides of the two legs is equal to the square of the hypotenuse, right? And so if we have a right triangle like this, okay, and my right angle is here, and I know that this side is 13, this side is 8, and I'm looking for that side. I know I can set up the equation a squared plus b squared equals c squared. And the most important part is c. I'm going to draw an arrow from the right angle. And when I do that, I hit C. I don't know if you realize this, but in any triangle, I don't care if it's obtuse, acute, right? The longest leg is always across from the longest angle. So, for example, those are regular polygons. I don't want a regular polygon. Okay. If I draw a triangle like this, okay, this would be an isosceles triangle. This just has boatloads of applications. Okay. And these two would be the same. Okay. By the way, that forces these opposite angles to be congruent as well. Okay. If I have any triangle, the longest side is always across from the longest angle. The shortest side is always across from the shortest angle. So if I call this maybe angle A, and this one angle B, and this one angle C, then the longest side is here. The shortest side is here. And the middle side is here. Absolutely, because it's directly across. And like I said, in the isosceles triangle, that forces, since these sides are the same, that forces the angles the same. Okay, the shortest side in this case would be this one here. And notice it's directly across from the smallest angle. All right, so now I have a challenge for you, and Chris and Tori, you're not permitted, and the other Chris, you're not permitted to tell anybody, so if you're watching this video with somebody, don't tell anyone. I have a challenge for you. I'll give any of you a $5 bill if you can come in and draw me a 1 inch by 1 inch by 2 inch triangle. Okay, if you want to pause the video and go ahead and try and bring me your picture on Tuesday. Now, let me tell you a story. Let's say you live in a nice little house. Okay? And that house is exactly 2 miles from Edwards in a straight line. And yes, all lines are straight. Absolutely. Okay, so there's Edwards. And this is exactly 2 miles, right? And you normally walk to school along those 2 miles. But then you make a new friend. Maybe somebody moves into the neighborhood. And you decide to walk to their house and meet them and then walk the rest of the way to school. Well, if I walk this distance here and that distance there, have I walked 2 miles? Hopefully you're thinking, no, you've walked more than 2 miles. Yeah. If I call that side A and that B, A plus B is going to be more than 2. Well, how is that relevant to what we just did? In any triangle, the sum of the 2 smaller sides must be greater than that of the third side. So for example, I could not have a triangle that is 3 inches by 3 inches by 6 inches because 3 plus 3 is not greater than 6. I could, however, have a triangle that's 3.5 by 3 by 6, because 3.5 plus 3 is 6.5, which is greater than the third side. That's true for any triangle. I don't care if it's an acute triangle, obtuse triangle, oh, excuse me, equilateral, it does not matter. All right, well, let's take this idea and let's test a couple. I'll make up some triangles here, some triples to see if they can make a triangle. And let's see here, 8, 21, and 9. And C could be 36, 10, and let's go with 20, 28. And let's do one more, D, whose measurements will be 5, 5, and 5. Okay. What the heck? I'll go ahead and put 2 more up here. Let's do 5 and 13 and 17. And then one more. Let's do 8, 40, and 39. Okay, so you go ahead and pause the video, test those to see if they can be triangles. All right, what you should be doing is taking the 2 smaller ones, adding them together, 6 plus 5. Is that greater than 11? It is not greater than 11, so this is not a triangle. Okay, I'll take the 2 smallest sides, 8 plus 9. Is that greater than 21? No, it is not. Therefore, it is not a triangle. All right, take the 2 smallest sides, 10 plus 28. Is that greater than 36? Oh, not 86, 36. What are you doing? Why, yes it is. Ding, ding, ding. We have a triangle. Okay. 5 plus 5. Is that greater than 5? You bet your boots. It is a triangle. 2 small sides. 5 plus 13. That's greater than 17, isn't it? Triangle. All right. 8 plus 39. That is greater than 40. Triangle. Very good. But this is actually, there's something even more powerful. Now I'm going to get rid of A and B because there weren't triangles, so they're not relevant. Okay. The Pythagorean theorem teaches me that if A squared plus B squared equals C squared, I have a right triangle. But a really cool thing is, if A squared plus B squared is greater than C squared, I know I have an acute triangle. All right. Oh, by the way, an acute triangle is not a triangle that gets a lot of dates, regardless of what Torrey Peters tells you. All right. If A squared plus B squared is less than C squared, then your triangle is obtuse. It's an obtuse triangle. That would probably look more like this, of a big angle, an angle bigger than 90 degrees, right? Okay, so of course we know that if A squared plus B squared equals C squared, then we have a right triangle. Pretty powerful theorem, discovered a long time ago when supposedly people didn't know a whole lot. I think they knew a lot more than we give them credit for. All right, well, let's test it out here. Let's look at problem C. We'll take the largest side is always going to be C. So there's my C. Okay, so I'm going to do 10 squared plus 28 squared, and I'm going to do 36 squared. And we will see what happens. All right, so 10 squared is 100. 28 squared is 784. Which will make the left-hand side 884, right? And 36 squared is 1,296. So C squared is larger. This is obtuse. It's an obtuse triangle. See how this works? This one, it doesn't matter what you call C because they're all the same. I'll put it there. We'll go 5 squared plus 5 squared and then we'll compare it to 5 squared. Well, come on. You ought to know that the left-hand side is going to be bigger because I'm going to get 25 plus 25 greater than 25. Absolutely. 50 is greater than 25. And so therefore, this is an acute triangle. All right, let's check this one. We're going to have 5 squared plus 13 squared. Some of you are wondering, how do I know which one C is? It's always the largest. So 17 squared. All right, so we're going to get 25 plus 169, 289 over here. Well, this isn't going to be even 200, so this one is larger. This is obtuse. All right, last one. I'm going to have 8 squared plus 39 squared. And I'm going to compare that to 40 squared. Right? Well, that's going to be 64. I know this is going to be 1,600. That feels too big. Yeah, I think 40 squared is 1,600. It just seems so large. Yeah, sure is. All right, and then I got to do 39 squared, and that is going to be 1,521. Now, if I add 64 there, I get a 5, I get an 8, I get a 5 and a 1, and that is less than 1,600, and so this one is also obtuse. Now, by the way, it looks like they're all going to be obtuse. No, they're not. And equilateral and acute don't have to be the same thing. Acute has to be, equilateral has to be acute, but not the other way around. I might have a triangle that's, say, 7, 8, and 9. Yeah, I'm pretty sure that's going to do what I wanted to do. If I square 7 to get 49, and square 8 to get 64, and if I add those two together, let me see. You know what I like to do? I like to take one away there, 48, and then think about that as 65. Well, I won't do that. That's just going to confuse you. Sorry about that. All right. I think it'd make more sense to go 50, but anyway, I can do it the old-fashioned way. Okay, that's going to be 3, carry the 113. 113 is greater than 81. This is an acute triangle. So what did we learn today? Well, we learned that, the two smaller sides added together have to be greater than the third side. And we also learned that if a squared plus b squared is greater than c squared, we have an acute triangle. If they're equal, we already knew that it's a right triangle. And if a squared plus b squared is less than c squared, we have an obtuse triangle. All right, Mr. Lawrence signing off. Hope you enjoyed your day off. If you celebrate Easter, I wish you a happy Easter. Good night, everybody.